Hello everybody. I'm a first year physics student at the college, and this summer I studied solar physics and space weather at the Goddard Space and Flight Center. So I looked specifically at this magnetic field surrounding the Earth. As I'm speaking to you right now, there are packets of solar wind the size of Mount Everest hurtling toward us at relativistic speeds. And this packet has the potential to damage our satellites, to impair communications or navigations, and many of our infrastructures here on Earth. Also can ionize our way our atmosphere. So it's very important to study this magnetic field that protects us. Okay. Thank you. So my 10 weeks at NASA were really amazing because this is a kind of a bubble around the Earth, but not a lot is known about this magnetic field. And I was really surprised at how little it's understood. You may have noticed the strange title of my slide, the magnetospheric squid, and that's because the magnetic field is very dynamic and it's very sensitive to solar changes, moving like a squid, kind of in the same unpredictable way. So there were some theories in the 80s and the 90s that the magnetosphere is similar to a kind of a bell. And too bad Mr. DeLuca left because there's a huge kind of great metaphor between music and science in this sense. And this theory is no matter how hard you push the magnetosphere with solar wind, it's the frequencies that you see in the magnetic field depend only on the bell itself, on the geometry of the magnetic bubble. But these magic frequencies in the 90s kind of uprooted this theory, and my advisor, my mentor, who's incredible, and his colleagues came up with an alternative idea. So he saw that in the solar wind, there are density pulsations right here, and they are basically areas where you have lots of solar wind particles and not a lot, not a lot, sinusoidal, and they're directly driving the magnetic field, causing it to oscillate. So theoretically, we should be able to see the frequencies in the solar wind matching the frequencies in the magnetic field. A unique phenomenon where you see matter and magnetic fields kind of really, correlated. So over my 10 weeks, I looked at 9 satellites, or 9 instruments, and I really followed the signal from the sun to the Earth at 95 million miles. So, okay, this is what I found. Go ahead, move this slide. Okay, so what you see in black right here, that's the solar wind data. And what you see in color, that's the satellites located in the magnetospheric field. And you can actually see a nice correlation. But furthermore, you can see that they match up remarkably well. And this is actually incredible. First of all, this is hard to find. Out of thousands of plots and hours upon hours of looking at data, I only found 35 separate events that have matching correlations between solar wind and the Earth's magnetosphere. And these matches, you can go ahead and move the slide. These matches show that, first of all, the solar wind isn't as turbulent as we think. It has really great patterns in it that are preserved, and thus we don't really know a lot about the sun itself because we think it's very chaotic and it really has these amazing microstructures. And second of all, there's so much more to learn about the sun-Earth connection. It's our closest star, and this magnetic field is the most important thing for our technological protection. There's so much more to learn. So if you're interested, check out spaceweather.com as well. It's pretty cool to understand what's going on up there. And I appreciate your time. Thank you.